right? Okay, welcome to again CL801, another lab over here. So what we are going to do today, we are going to learn how to set up crystallization using vapor diffusion. And in vapor diffusion, what we are going to do, we are going to do hanging drops, right? Now before I move on, I have to introduce you to my team who has really helped me out for today's experiment. Like it's going to be Sonali, right? So then, right? Mayuresh,
Hello.
right? Sandesh, right? And turn around, Rupesh, you and Abhijit both are standing behind, right? So they are making all of these are making this practical possible. So all thanks to them. So what we are going to do, so as I had already discussed in the previous video, that we have to design the grid, right? So it is going to be the concentration of sodium chloride on along the rows. So on the plate I can show you, along the rows we are going to vary the sodium chloride concentration, along the column we are going to vary the pH of the acetate buffer. So it is going to be from 0.4 to 3 molar for here, and here it is going to be 3.5, 4, 4.5 and 5 pH of the acetate buffer what we are going to use. And let's see which particular condition gives us the best crystal. Only the phase diagram is going to reveal what kind of crystals are we are going to get, right? Can I have some water please, so I can show them on the dummy mode, yeah, how to set up crystallization. So for that I have to make some space, right? So can you please make some space, and it is a non-sterile plate because I'm using it for the demo here. And then these are the clean plates which everybody else is going to set up crystallization with, right? So you are going to open the cover, of course, and can I also have the cover slips please, right? And gloves for my side, right? So I am going to just fill up the well with water. This is just for the demonstration what I am going to do, right? But actually what you have to do, you have to set up the grid. Yeah, you have to make a pipetting scheme, right? A nice pipetting scheme what you have to make, and then you have to pipette in the sodium chloride first, then you have to pipette in the buffer, and the remaining volume you are going to make it up with water. And the reservoir volume what we are going to use for today's experiment will be 500 microliter, which is a very standard volume what is being used. So these are the siliconized cover slips which we had already done. So we have it here, right? So they are here ready to be used, and here there are tweezers. To begin with, what you do, you fill up the plate with your solution, right? So for, as I said, I am using water for this purpose, and I also need like P1 ml pipette and its tips, no, not 1 microliter, 1 ml pipette, P1 ml, and also the other tips we need. Right. So here in this case I am straight away putting 500 microliter of water, yeah. But in real scenario what you are going to do, the 500 microliter will be made up by salt, buffer and water put together. But in my case I am just using like straight away 500 microliters of water. So I had set up at 500 microliter, right? And I am just pipetting in some water, yeah. So I am going to pipette 3 wells here, 1, 2 and 3. Now whenever you are doing any pipetting in the plates, it is always good idea to use the other hand to control the pipette. If you do just like this, then your pipette might go stray like this. So always use the other hand fingers to keep it stable so that it goes straight into the well, right. If you would realize, and this is quite a big plate, so there is very little chance of doing mistakes, but then when you are working with this 96 well plate where the wells are quite tiny, and if you are happen to do the reservoir pipetting by hand, then it is very easy to mix up the wells if your pipettes are not stable. And also while setting up the drops also we are going to use the same technique, that way it remains more stable, right. So now I have 3 wells left because we are going to set up 3 kinds of drops. One is 1:1 ratio, another is 2:1 ratio, and another is 1:1:1. Now I have here the protein solution. One is here 10 mg per ml, another is 20 mg per ml of lysozyme. Yeah, 10 mg per ml and 20 mg per ml both are there. So I will just pick up like 20 mg per ml. So that has come in my hand, right. So what I am going to do now, I am going to first apply the grease. The first step is do all the pipetting, right, do all the pipetting, right. So you have to work as clean as possible. So do all the pipetting in your plate. Don't worry about the evaporation if you are not leaving the plate overnight, so there won't be much evaporation happening, and because we are working at room temperature and not at 40-50 degrees, so the evaporation rates are very little. Be swift with your pipetting of the solution and try to be quick but not to mess up while pipetting. So that's the caution what you have to keep. You have to be very careful about that. So once you do all the pipettings, all the conditions, your plate is ready, you are going to grease the plate. What do you mean by grease the plate? So for that we use this vacuum grease, right. So nice tube we have, right, and we need a syringe, right. Now the syringe what we have here is a 20 ml syringe. It should be a sterile syringe. Please don't reuse the syringe. Yeah. Now this syringe, Rupesh, just zoom in. The tip is quite pointy, right. So it's okay, it's good. Some of the syringes, if you really have the tip which is bigger, then you put in some of those small say pipette tips over here, and then you can cut it to make the diameter almost as big as this one. So then it is quite easy to apply the grease, right. So how do you fill the syringe? It's very straightforward. Open it and then you have to fill in the grease in this syringe. Fill it, yeah. So let it be seen on the yeah, should be good enough. Then let's close this tube first, yeah, and then we will push the plunger back in so that grease is nice and compressed and it comes out here, right. Now every person is different. How comfortable are you pushing it with the thumb? If it is too long for him, don't fill it too much, yeah. In crystallization, the caution has to be, you have this concept of repetitive movement injuries, right, because you keep pipetting, so you kind of develop those injuries for your thumbs, right, if the pipetting is too much. And especially if you are doing repetitive greasing, then you can feel bit of pain in your thumb, but then you have to exercise your finger muscles quite a bit, right. And Rupesh, now you have to please come in closer. So you make sure that you are working on a clean and clear bench. So this I don't need anymore. So this is the plate where all this conditions have been pipetted already. Now we are going to apply the grease. Now see, there is a rim here, right. Can you see this rim of the well, right. you have to apply the grease in one continuous flow. That's the best way of applying grease, right? I'll also show you if you don't do it what happens, right? So all you are going to do, you are going to apply the grease in one continuous motion. Just apply just right amount, don't break it, right? Don't break the continuity, and that's it, right? That's it. So here it has not been applied properly, and yeah, so now see the entire rim is full. Apply to the next well like this, see, in one continuous motion. Always this hand is always going to help you to guide it along the rim. And this is my third well. So as I had pipetted only 3 wells, so I am going to grease only 3 like this, right? Now if you are discontinuous like this, so you break here, then you put grease here, then you put grease here, so that's a very discontinuous grease which I had applied on the rim. I'll show you what happens by inverting a cover slip on top of this. Now these are the siliconized cover slip what we have. You take few, right? So I will just take 4, then you invert it. They are nicely visible against the black background to you, yeah, and if you have like white background then it is so very difficult. So I'm just taking like 4 cover slips right now, right? And then we are going to set up big drops because we are doing it for the first time. Now see, this is a P2 pipette, like 2 microliter pipette which I have, right? And where are its tips? It's here. Can I have them? Yes, thank you. Right, so let's open them. Now see, when you have the pipette, there are always you are going to push the plunger in 2 phases. One is 1, and then whatever is the residual remaining, you do it 2, right? See again, 1 and 2. That's how you completely push all the liquid out. For crystallization, you shouldn't be doing like 1 and 2 movement. You fill it up and do only 1. If you do 2, you are going to insert air bubbles into the protein drops, which is not a good idea, right? Not a good idea, right? Number 1, because of the air, they might get denatured. Number 2, because if air bubble is there, you might miss some crystals because it might get hidden behind that air bubble. Yeah, when we will be doing the visualization, we can actually see some of the drops by deliberately putting in the air bubbles and see how it looks under the microscope. It's very deceiving. You might miss your crystals if they are small, particularly if they are small, right? So you take the tip, right? Make sure it is nice and secure. We are going to do 3 ratios, right? So suppose, so where is my protein gone? Yeah. So you take it and you pipette in all the protein on all.
So is there an order that protein should be put first? Or?
Yes, protein first always. It's 2 microliters, so that is 1:1. See, I had pushed in only once the plunger. 2 microliters. This is going to be 2:1. 2 times protein and 1 time reservoir. So I'm going to put in total 4 microliter of protein and then 1:2. So I'm going to pipette in only 2 microliters here. Right? Let's keep the protein back. Change the tip. Yeah, when you are pipetting the protein, you should use 1 tip always, right? And then we are going to do 1:1. Now first well is my 1:1 here. So I am just putting in 1:1, right? This is 2:1, so 2 times protein, 1 time reservoir solution. So here also I am going to put only 2 microliters of reservoir solution, right? And then now it is 1:2, so I have to put 2 times the reservoir solution and 1 times protein.
I have a question.
Just can I just finish the pipetting? Is it related to pipetting? Yes.
So do we touch the
Yes.
pipette to the protein?
Yes. So you are touching it not exactly on the drop, but just next to it, so that it comes and merges into it, right? This is 2 times the reservoir solution, like this. 1:1. This is 2:1, and this is 1:2, right? So every time when you are changing, you have to change the tip, because your reservoir condition is changing every time. New reservoir, new condition. In my case, it is just water, so I haven't changed it. But in principle, whenever you are every well is a unique condition, so you shouldn't have the cross contamination, right? You pipette in here to here, change the tip, pipette in here to here, change the tip, then pipette in here to here, then change the tip. At times when you are doing this pipetting, it could happen that you might accidentally touch your tip to the grease. Throw it right away. Throw the tip right away. Take the fresh tip and then start, right? And now once all my pipetting is being done, what I am going to do, I am going to take this cover slip and I am going to invert it. See, this is where the drop is. Can you show the drop? Yeah, and I am going to invert it, so it is not going to fall because of the surface tension, right? And I am going to put it carefully on the rim, right? And then with some tip, you just give a gentle pressure along the rim. Now you would see what was smudgy before, because of applying the grease, is looking very clear. This is good greasing, because the entire rim is looking clear, right? It's looking very clear. That's nice, right? Then you take the next cover slip, you invert it, and then do it like this. See, there is a complete continuity, what you would see over here, of a clean rim. This clean rim is quite continuous and round, right? I'll invert the third one, right? And again apply a bit of pressure like this. That's done. Now remember, this the third one more, the fourth well, where I had deliberately applied the discontinuous the grease in a discontinuous fashion. What happens if I invert the cover slip onto it? Yeah, you will see it is not, there are gaps in between, the patches in between. From here evaporation is going to take place. Your drop will dry out. Before it equilibrates, it will dry out. So a good sealing is essential, right? A good sealing is essential, right? And then we take this plate to the microscope and then we will observe, right? So now you can start with your crystallization. Once you are done with your crystallization, I can tell you how to do the visualization under the microscope, right? Okay. Okay, so now we are done with our crystallization. It's time for imaging, and I'm not going to explain how to do it, because these guys, is Priyanshu, that's Karthik, so they know already how to do it. So I leave it up to them to explain like how to image a crystal. It's extremely easy, and we are going to do it on our microscope, which they are going to explain, and also they are going to explain the software. It's all yours, Priyansh.
Thank you, sir. So, what for the imaging, what we are doing is that we are having this stereo microscope over here, and so there are some basic functions in this microscope. So I think that this I can demonstrate through if you can. Yeah, यहाँ पे camera. So in a microscope, so that's how the microscope looks. That's how the microscope looks. Over here we keep the sample that we need to view, which I will be keeping over here. So sorry. So we will be keeping it in such a fashion that we focus it, and which will be actually viewing it. On the bottom we have the bottom light, and on top we have another light which can be controlled by the software, which we'll be viewing ahead over there. Over here is the light control panel. The intensity can be increased or decreased accordingly, the buttons. These are some other lights which mention that how to connect it to the PC through USB, through Wi-Fi, and there are many options. Now this is the focus. From here I can focus the microscope. So it's over here you can even see the movement from this. There is a significant movement accordingly the movement is focus is the focus. From here we can focus, and this for the zoom. So there is zooming in, zooming out. Over in this unit we have the camera placed in the microscope, so the image is captured, and this is connected to the laptop over there. So on the laptop we have the software installed, and which will be viewing. So that's the basic assembly we have right now over here, and thus correspondingly we will viewing how we are actually dealing with it. So I will ask Karthik to share the screen.
Okay.
And
So yeah.
so we have the software installed over here. So the screen is shared, right?
Yes.
Okay, great. So the screen is shared, and we have the software installed over here. So the model name of the brand is Leica, and of the microscope, and the model is EZ4E, and we have installed the corresponding software, as you can see on the screen over here, that is LAS EZ. So we will be opening it. That's how the general UI looks for this software, and which is currently loading. All right. So yes, right.
Okay.
So since we have no sample over here on the microscope, there's this is the camera section. Okay, this is the camera section. Over here you see the camera, whatever we are viewing. Okay. On the left panel there are various controls for the camera, and like as you can see. So the first control on the left is there are multiple controls for the camera. So it is for manually adjusting the exposure, gain, saturation, etc. The next to it where the cursor is, automatically the camera decides. On the right we have the in light settings, which are the two lights which I told you from the bottom and from the top. So it's the incident and the transmitted light, and accordingly we can adjust it. There are various other functions like adjusting the white balance, and this is the LED optimization is the light is optimized by itself, and this is the capture image. So by clicking over here we can actually take the image, so which we'll be doing ahead. So the next below over there, Karthik, can you set it to manual?
Yes.
Yeah.
Yes. It's
So
set.
below over here we have the exposure, which we can adjust actually, which will be just be seeing. Can you minimize this thing, exposure thing? Okay. The next option we have is the input option. So it is by default the options that we have, and the next tab we have is processing. So shading, if you can open. Thank you. So there's there's no by default any option. So that's it. Sharpening we have, so we can actually sharpen the image depending on a need, which we'll again seeing. And over here, it's the line. So I think it's about the grade lines, but we will check it out in the DO course. So now what we will be doing is we will be placing the sample now. over here on the microscope. So you will be able to see the screen. So what I will do is first I will try to coarse focus it through the eyepiece, and then let's see that where the sample is actually.
You should take it a little left,
Yeah. Okay.
a little above,
Okay.
a little down. Yeah.
So that's the
Yeah,
drop,
perfect.
and I will zoom it out for you. So on the edges, if you can see, this is the gel, the grease that we placed on the corners, and the center you can see the dot over here.
This is the droplet.
Yeah, that's the droplet. I'll focus it according to the camera we have.
And
Okay.
print sheet would be better if you zoom it a little.
Yeah. Now we zoom the drop, and
Adjust the position.
adjust the position.
Perfect.
Again, we'll zoom a bit more. All right.
Yeah.
Looks good. We'll focus if needed. I think this is fine.
And afterwards, now we'll be adjusting the exposure settings. That will help us get a better image. So for each drop, this needs to be adjusted manually if required, and not all the drops can be imaged with the same settings.
Right. Because it's due to the varying size of the drop, varying height of the drop.
Yeah.
So there's a change in the sharpness of the image.
Yeah.
All right.
After adjusting the exposure, we'll go to processing and sharpen our image with medium sharpening.
You can actually medium sharpen, or we can also show robust sharpening over here.
Yeah.
What happens in that case? Yeah, so there's some slight difference. Maybe when we have the crystals, it will be more clear.
Yes.
That will be better.
Yeah.
Also, if you can show the flip horizontal and vertical options.
So yeah, we can even flip it with these options.
So if needed.
Yes.
In any kind of
So
setting.
I'll go back to.
Great.
Okay. Now after the settings had been adjusted, we just acquire the image by clicking over here. And we can edit the file information.
This is P5A1.
It's not working.
I guess
Okay.
you should save it.
Yeah. So
It is.
okay. The image is saved.
Yeah, so the image is right now saved, and correspondingly, even if we can print it if needed. Can you try that option, Karthik?
Yeah.
Great. So as a PDF we can save, or there are multiple
There are
options?
multiple. We can select the printer which we want. Currently, since there is no printer attached, only the softwares are being shown.
So we can have it as a PDF over here. As JPG, it's already saved over here, and from the file option we can have the image extracted to a PC.
Yeah.
So that was about the imaging part of it. So yes, that's some setup. And correspondingly, we can have batches of these images, and we can actually monitor all the images and see that where, and again in due course of time, we can correspondingly from following the same fashion, we can take all the images. And
only one thing to remember is all the images should be taken with the same, same settings for the same droplet.
In fact,
throughout the course of time.
Even the same zoom, so the zoom should be same. The focus can obviously vary, but the zoom length should be same. It should be just fixed at a particular instance. So yeah, that's all about imaging, and yeah, thank you so much.